Still working with logarithms, and in this section we're going to talk about inverse properties. What happens if you have a composite of a log and its inverse function, an exponential? If you look at these two expressions, you're going to see that you have a base, in other words, an exponential to a log, and you have a log of an exponential. So logs and exponentials are tied together in both of these problems. And what you're doing is you're taking an exponential and you're undoing it with a log. Or you're taking a log and undoing it with an exponential. What you get is you always get what you started with, which is going to be a 4. Remember, there's a base 10 here. In this problem, there's one step that's missing. This is really 5 squared is 25. Now this base and this base are the same. So now you're taking the log and then you're undoing it with the exponential, and you're ending up with 2x. You're not solving for x, you're simplifying this. It's not an equation, it's just an expression. These are the two properties, and again, this is taking the log of an exponential, you get where you started, and you're taking the exponential of a log to the log power, and you're getting where you started, which is your x as well. Notice that these are both composition functions of inverses. Composition functions of inverses, and they undo each other. So how do you do certain problems with this? First of all, looking at these, you're looking to see, are the bases the same? Yes. So you're left with x. The bases are the same, negative 3x. The bases are not the same, so this is really log base 2 to the 4x power, 2 to the, 6x power. So I know that this is now going to be 6x. Again, it's simplify, and this would be 20. The other type of questions you're going to have is to find the inverse of y equals 4 to the power of x. Finding the inverse is the same idea as switching the two. So this is going to be x equals 4 to the y. Same thing here, x equals ln y minus 5. These are basically the inverses. But in this one, what you want to do is now switch the form, so you can say it's the log base 4 of x is equal to y. This right here is the inverse. So you could say, yeah, you don't have to go any further than that. That right there is the inverse function. This one, there's a 10 here. Nope, I'm sorry, there's an e here because it's the natural log. So it's, again, changing that form. E to the x equals y minus 5. And you're not done. Y is equal to e to the x minus 5. And again, that would be the inverse of this natural log function.